Our next technical session is on MISRA C in the ISO 26262 context. For this session, we have Mr. Andrew Banks, Chairman of the MISRA C Working Group and Technical Specialist at LDRA UK.
Hello and welcome to this session, MISRA C in an ISO 26262 context at ESSS 2021. I'm Andrew Banks. In this session, we'll cover 4 short topics. A quick history of MISRA C in a 26262 context. We'll go into a little bit more detail and then briefly cover achieving MISRA C compliance. This will be followed by a short Q&A session, and if any participants have a question, please enter it in the Q&A panel on your screen. So first, a quick history of MISRA C. As many of you will know, the language C was created way back in 1972 by Dennis Ritchie at Bell Labs. A mere 4 years later, the first static analyzer was created, also at Bell Labs by Stephen Johnson, because even then they realized that C compilers allowed you to do things that were not a good idea. Then in 1978, the book that most of us know well, the C programming language, was published. Fast forward a few years and the C language was finally standardized as ANSI C in 1989. This was quickly realized to be a good thing, and so ANSI C was standardized internationally as ISO C a year later. The 1990 version of the standard is identical to the 89 ANSI C. But even within standards, things don't stay the same. And so in 95, there was an update. 1999, a fairly big revision. 2011, another update. And 2018, there was a TC in all but name. And all being well, there will be a new version in 2023, adding some more features. The key point here is very few of you will be using ANSI C anymore, although we still hear people say, I'm using ANSI C. Now, despite its popularity, after all, the Linux operating system is written in C mostly, there are a lot of drawbacks with the C language. The standard itself is incomplete. There's a lot of undefined behavior where the standard says, in this case, the behavior is undefined. There is a lot of unspecified. The semantic difference between undefined and unspecified actually is broadly irrelevant to most people, but it means we're not telling you what we're going to do. There's also a lot of behavior that is implementation defined. That's where the compiler can do what it likes as long as it tells you what it's going to do. The C language itself, it's open to misuse and obfuscation. Over at Stack Overflow, there's a whole forum where people get smarty points for making the most obscure and unreadable code. There's a lot of misunderstanding of some of the features of C. And perhaps one of the big ones is there's no runtime error checking. If you want to runtime error checking, you have to write it yourself. Now, there's many ways of dealing with these. MISRA C is one of them. So who and what are MISRA? Well, in 1994, a group of the UK automotive industry had published a document called Development Guidelines for Vehicle-Based Software. These are known as the MISRA guidelines. And it was the first publication addressing functional safety within the automotive world. And note, this was commenced more than 10 years before ISO 26262. After that was published, the same group, with a few extra people, created the guidelines for the use of the C language in vehicle-based software, or MISRA C. And this came about because more and more software was being developed using the C language, and the industry wanted some guidance of how to do that. And just to put this into a timeline context, IEC 61508, the granddaddy of functional safety standards, was published in December 1998. So all of this MISRA activity predates the international standardization community. So, first published in 1998, MISRA C. Almost as soon as it was published, questions were being asked of, well, can we have a MISRA C for the aerospace world, the medical world, nuclear industry? And people went, well, what's wrong with MISRA C? That's automotive. So the second edition had this paradigm shift, and it's guidelines for the use of the C language in critical systems, all critical systems, or any critical systems. And then in 2012, the third edition brought in C99 into scope. And again, this is guidelines for the C language in critical systems, and this was revised a little bit in 2019. So what's this all got to do with ISO 26262? Well, as you saw, many of the same people that created the original MISRA guidelines then became involved with ISO 26262. And 26262 says we need guidance for creating modeling, design, or programming languages. And there, front and center, example 1, MISRA C is a coding guideline for the C programming language. There we are. It's there. That's what this is all about. Now, that table 1 that it refers to specifies a whole list of features, and we'll come to some of these a little bit further on. But that's not all. Further into the part 6 of 26262, there's section 845, which is the design aspects. And it talks about some of the features and some of the design considerations you need to think about. And what does it say about those? For the C language, MISRA C covers many of those principles. We go a bit further into the V and V parts. Table 7, Table 10, the unit verification, and Table 10, unit verification and the integration. They talk about static analysis. There's MISRA, control flow analysis, a lot of the rules, data flow analysis, some more of the rules. And here we are, and these are the features that we're looking for. Unit 7, Table 10. And interestingly, for the second edition, these tables were restructured. Before, it was your unit design and then your unit test. Now, they've been restructured in the same way as MISRA. So we've got the unit verification maps to the single translation unit guidelines in MISRA, and integration maps to our system-wide guidelines. Again, the benefit of MISRA having a lot of influence in the 26262 standard. So let's go into a few of these in a little bit more detail. So back to table 1. Number 1, enforcement of low complexity. Well, let's start with one that MISRA C doesn't mention much. We deliberately don't get into the topic of measurement and metrics, other than saying you need to do it. But back in 1995, MISRA published a report on software metrics, which offers good, sound advice. And more recently, a software quality measures working group has been established within MISRA to look at the whole topic of software metrics and how we improve the measurement of software quality. Complexity. Keep it simple. Designs as simple and small as possible are easy to understand and maintain. The more you make it complex, the harder it is to design, maintain, and test. So a nice simple code with a nice simple flow, it's easy, we can look at it, we know what's going on. More complicated code, here we have an example from a particular piece of open source software. Open source is not particularly relevant. It's something we can test and publicly talk about. Code with a complexity of 98 is just impossible to understand. And for context, the infamous Toyota unintended acceleration case centered around a function with a complexity of 97. My lawyers will remind me that Toyota was cleared of any coding violations. But code like that is just impossible to understand, maintain, and test. So keep our code simple. But complexity is a complex measure. Some structures, like case statements, by definition result in a high complexity measure. That's just the way that the algorithm for complexity works. So bear that in mind and always think of complexity together with essential complexity, which simplifies some of these structures. So 1B, use of a language subset. Well, guess what? That's what MISRA C is. And MISRA C itself defines a subset of the C language in which the opportunity to make mistakes is either removed or reduced. I emphasize the reduced because even if you follow MISRA C to the letter all the way through, that doesn't guarantee no problems. But it will help, and it will stop you making a lot of the mistakes that you don't want to do. 1C, enforcement of strong typing. MISRA C has a whole section and a large number of rules that we call the essential type model. And this is an attempt to bring stronger typing to the C language. C itself is very weakly typed. And that means you can treat floats as integers without a problem. You can use Booleans in equations. Not a good idea, but you can do it. So MISRA has rules to try and restrict some of the big problems that this may cause. 1D, use of defensive implementation techniques. And this is introducing guidance, more of a good practice rather than a subset, but this is to try and make sure that you understand what your code is doing. For example, if you have an if-else-if structure, we tell you to make sure you have the else. Switch statements, we tell you to have the default clause. While do loops, we try and give you a structure and guidance of how to create them. And for loops, we try and stop you doing silly things in for statements. We also have rules about unreachable code and unused code. I do a longer presentation in this particular area that talks of a case study around the Apple SSL bug of a few years ago, because if the MISRA guidance had been followed, that Apple bug would not have happened. But in summary, a project should not contain unreachable code. We insist on putting the braces around compound statements. Now, some people suggest these rules are fussy, awkward, unnecessary, but they themselves would have stopped Apple's embarrassment with the go-to-fail bug. And if you want to see more details of that, the CVE is there, and I have done other presentations that go into this in a lot more detail. Moving on, Table 6 adds some design principles. And again, MISRA covers some of those. I won't go into all of them, but a couple to think about. 26262 requires a function has one entry and one exit point. And this is broadly interpreted to mean you shouldn't do early returns, or you shouldn't have multiple returns. Now, a single entry point pretty much is a given in a structured language. There's a lot of debate as the usefulness of a single exit point in a higher level code. In assembler, yes, it makes sense. This rule can make error trapping more complex if you don't have early returns. So in many ways, this is an example of a MISRA rule that you should use where necessary, but don't use it when it makes sense not to use it. And that's the basis of a lot of MISRA rules. Similarly, no dynamic objects. And this is common across most of the functional safety standards. And in MISRA, it's embodied through a directive and then some detail in several rules. The rationale for this is that the C standard library is poorly defined. Plus, you have all the known problems of heap fragmentation and such like. There's also a lot of programmers are lazy and don't check the return values of malloc, and that may mean you have a null pointer. Interestingly, the Joint Strike Fighter F-35 coding guidelines, which are based on MISRA C, actually permit dynamic allocation during program startup. And that perhaps is a deviation that you may want to consider. MISRA also has a mandatory rule about initialization of variables. And in some ways, this is a rule that perhaps shouldn't need stating. However, quite often people leave variables uninitialized. The standard requires static variables to initialize to 0, unless you explicitly initialize them otherwise. But actually, 0 is not always the right value. For example, if it's a divisor or a pointer. Now, put all this together and people talk about being MISRA compliant. Well, what do we mean by that? Well, there's been guidance right from day one in the MISRA standards, in the early chapters. But we decided that actually this needed more emphasis, and so that guidance has been pulled out as a separate document, and it's harmonized between C and C++. So this tries to make it clear of what you need to do. It's available as a free download from the MISRA website. So it gives a clear definition of what we mean by MISRA compliance. So when somebody says to you, oh yeah, I'm MISRA compliant, you can say, oh, show me. And we'll come on to that briefly in a second. It now provides clear guidance for reclassification of some of the rules. You can make required rules mandatory. You can make advisory rules required or mandatory. You can actually disapply advisory rules. You can't ignore them. You can disapply them, though. It has guidance now of dealing with adopted code, and that's increasingly becoming a concern, especially when people are looking at operating systems and adding third-party open source code. It clarifies what we mean by deviation and what you need to do. I don't want to hear of people saying, oh yes, I'm MISRA compliant, I've just deviated all the rules. And we also have a mechanism for establishing permits. That's often now a case between a developing company and the customer. A reminder, compliance is not for the organization, but for the deliverable. And it's not really applicable to the software, but to the development lifecycle. Compliance does not mean no deviations. You can have deviations. That's why we have the process. But it means no unresolved violations. So you've done something about the violations reported. And compliance is achieved when basically you've followed the rules. Adopted code covers anything that is developed outside of your current project, and it may or may not have been developed in accordance with MISRA C. But if you're using it in your project, you still need to verify it against the MISRA C guidelines. That may mean you have violations against the rules. But as soon as you start modifying a source file, it is not adopted code. Briefly on deviations, sometimes a violation may be justified. I'll say that again, sometimes a violation may be justified. Somebody who tells me they want MISRA compliance with no deviations has not read the book. Where you have to violate a required rule, a deviation is the appropriate way of doing it. Hacking the code so that it shuts up the checker is not the appropriate way of handling a violation. But there are legitimate reasons. Sometimes code quality. Accessing the hardware, for example, where we know the rules are a problem. But that's because 99% of the time you're not accessing hardware, and so on and so on. The deviation should not just document the existence, but document why it's required and what you're doing about it. For example, extra testing. How do we check compliance? Well, you can do a manual code review, and you do need to do some manual checks on some of the undecidable rules. But please do not ask me, as a customer has recently, to do a manual review on 10,000 lines of source code. That's not what I want to do with my time, and nor should you. You can use a lightweight tool, such as many compilers now include. This is fast, usually only checks a subset of the rules, and detects the easy-to-find defects. They tend to be optimistic. You get false negatives rather than a positive sometimes. Or you can use a heavyweight qualifiable tool. Yeah, they're slower. That's because they're doing a deeper analysis, checking all the rules. And they're more likely to find the hard defects as well. And these tools, they tend to be pessimistic. You may get false positives, but surely it's better to flag something as being of interest than not flag something that is of interest. So compliance can be achieved when you followed the guidelines. And the evidence, and if somebody says I'm compliant, this is what you ask for. A recategorization plan, if applicable. The enforcement plan, how they've enforced the rules. The compliance summary, how well they've checked the rules. And the deviation records. And before people say that's a lot of bureaucracy, the first three is a single spreadsheet. So, in summary, MISRA C, it's a widely respected safety-related coding standard, but it's equally applicable in security-related environments. In fact, all high integrity, high criticality, high reliability. MISRA C has evolved from being a pure automotive standard into a pan-industry one, but still has that specific applicability in the automotive world, and especially ISO 26262, and it will continue to evolve as new standards, C standards are produced and other constraints as they're identified. For more information, feel free to get in touch with me or LDRA directly. I hope you've enjoyed that. If you have any questions, we'll take them now. Thank you very much.